Alright, welcome to this demonstration of my camera heat mapper for Maya. Now to install it, we're going to add it to a Maya shelf. You can pick whatever shelf you like, or create a new shelf for your custom tools. Then open up the file that you downloaded, and find this .py file. You can click on that, drag it, and just drop it into your scene. Then you'll see that you now have the tool on your shelf. So let's give that a click to launch. So we can see here it's automatically captured a list of the cameras that are in the scene, as well as a list of all of the mesh. These meshes with a slightly different icon suggest that they've been referenced, which you can see over here. For your list of cameras, you can click on them, and when you do, you'll see that we automatically look through the camera that's currently being selected. This is the list of cameras that's going to be looked through for the heat mapping. You can enable or disable cameras by checking and unchecking here, or by selecting a range of cameras, then right-clicking and using the enable or disable selected functions. Now for each camera, it's going to export the contents of what it sees through a certain frame range. The simplest and fastest is to use the current frame, which is set here. This means that whatever your current frame is set to down here, that's the frame that's going to be checked through. We can change this to a range of different options. Clicking here, we have access to the playback bar range. From 1 to 25, you can see that's taken this range from here to 25. The full range, starting from here, and it's going to go up to this 50 over here. We can copy the render settings, and we can look at the keyframes. The keyframes is going to look at the first and last keyframe set on the camera. So when we click on this camera, we can see here that the first keyframe is set to 1, but the last keyframe is only set to 22. But this is going to scan up through all of the ancestors of the camera. So we can click here on this offset and see that this has a keyframe on 23, and this assembly level null has a keyframe on 24, resulting in a total frame range of 1 to 24. Down in the mesh area, we're able to use the same commands to enable and disable what we want to be processed, using right-click and standard clicking. The frame range used on a camera can be customized on a per-camera basis. So let's start by setting this to keyframes. Then we can look at the bust cam, and we can decide that we want that to be from frame 5 to 15. Maybe we want the close-up to be from -5 to -3. And we want the far-off camera to be looking at frame 17. These are a few different ways that we can set the frame range that we want. If you try to set a frame range that doesn't make sense, the previous value will be used instead. Then, if we want to reset them, we can right-click and use the clear user override function. If we don't and we leave them overridden, then we can go up to keyframes and we can change what the source is. Those that have been custom set are going to retain their value. In the mesh area, we can get an indication of what's being referred to by either holding the mouse over the entry and looking at the full name, or clicking on it, and therefore seeing it highlighted in the scene. It'll be selected with its name written on top of it. Next, we have access to two different scan tabs. Polydistance from camera, which will find the center point of each polygon, and then it will determine the distance between that center point and the camera. Or poly size in camera, which will determine the area of the shape of each polygon in 2D against the area of this resolution gate, and it will calculate the percentage it's using. Let's take a look and see. So with polydistance from camera, all of our cameras enabled, and all of our meshes enabled, we're going to create a heat map. Alright, so the scan's done. Here we can see that this orange area was quite close to the camera. This was a similar distance. This red area was very close, and so on. So this is the amalgamated data of all of the cameras visible at once. We can look through our perspective camera to get a better idea of the overall use of space in the scene. By looking over here, we can see that these faces were occluded by the man. These faces were occluded by that cylinder. These faces were occluded by the second cylinder. Behind the car, space was occluded. And by these mountains also, there was occlusion. But then this area was once again in camera. Next, let's take a look at a size in camera scan. So for that, we'll click down here and change to poly size in camera. And run that creation again. Alright, so now we have a poly size in camera scan complete. If we look through our animated camera, we can see that all of these faces are extremely large in camera. In the bust, although these eyes are quite close to camera, because of the size of the polys, they're actually a cooler color. These are facing more towards the camera, whereas these are more angled away, resulting in them being smaller. That's quite large in camera. So then we can look through our bust camera, and we can see that there are some areas that have missing data, like this polygon here, and here, and here. That's because their center point has been occluded. They can be captured into the dataset by using detailed occlusion, which is going to scan more points on the surface of each polygon to make sure that they are in camera. So with that, we've now completed a detailed occlusion scan of poly size in camera, and we can see that around the edges there's no longer any loss of detail. This does come at the cost of a longer processing time. Now if we want to go in the other direction and really speed up processing time, we can ignore occlusion entirely. So that's very quick. And that means objects will not occlude each other, although they will still include themselves. So we can go up here and look at the ground and see that this ground is still being included by this ground on the same mesh. Now we've got this Rex here in the background, and we can see that he never gets colored in by the scan at all. That's because of the far clip plane, which is currently set to 3000 units. Which extends up to roughly this area over here. If we want to capture him in the plane, we can increase that further. And now we can see a whole new range of data created. Now if you close the script right now, it's going to leave everything as it is. When you're ready to clean up, you can run your script again, and just click on clean up over here. And then it's good.